Hello fellow Unreal Engine artists, designers and developers, and welcome to another episode of the Landscape Materials series. Today we're going to be implementing Runtime Virtual Textures into our landscape. It's going to be quite involved, so grab a coffee, stay focused, and we'll work through it together. We're going to cover a lot in this video, but there are also further RVT refinements that I'll cover in a future episode. Now, there are two main reasons for using RVTs. The first is that instead of doing all our complicated maths and texture calculations in our landscape material every frame, we're projecting this material from the top down on a very large virtual texture. We only have to do this every time the material changes, not on every frame. So this texture is then broken down into tiles across the landscape, and depending on your camera view, only the relevant texture tiles need to be shown. And also, if tiles are hidden behind mountains, they don't need to be shown as well. Now, there are advantages and disadvantages to using RVTs, which I'll talk about as we create them. But before we do that, we need to set up virtual texturing for our project. Okay, here we are in our project, and before we can do any virtual texturing, we need to switch it on in the project settings. So go into Edit, Project Settings, and if you search for virtual, you'll find this option here, Enable Virtual Texture Support. So you want to switch that on. I would suggest that you switch off the Enable Virtual Texture on Texture Import. It's not an absolute necessity, but if you leave that on, then any future textures you import will be set up as virtual textures rather than regular textures, and you will need to go into your material and change various settings. It's a bit of a headache, so it's better for you probably if you switch that off, and you'll need to restart your project.
A few moments later.
So that probably took a little longer than you expected. It had to recompile around 7,000 shaders to see if any virtual texture support was required, but now we're back in the project and nothing seems to have changed. So to implement the RVT, there are 4 steps that we need to execute. First thing is we need to set up the RVT asset. So let's go into our content, and at the top level, we'll create a new folder, call it RVT, double click and right click, and in under texture, we've got Runtime Virtual Texture. So select that, and I'm going to call it RVT underscore color. And if you double click to open it, it has various parameters in it. The most important 2 or 3 are here in the middle. It's the size of the virtual texture in tiles. Basically, the larger your landscape, the more tiles you'll require, and also the size of each tile may need to increase as well. We can play around with these later, but for now, let's set it to 10, which is 1024 tiles and 256K per tile. We can always come back and change that later. Click on Save, and you notice that what's going to be stored in this texture is not just the color, but the color, the normal, the roughness, and the specular. There are various other options there, but this is what we'll go with for now. So close that down, and we've completed step 1. Step 2 is we need to tell the landscape that we want to write to this runtime virtual texture. So go to your landscape and go down until you find the section on virtual textures, and it's got this draw in virtual textures array. So click on plus to add an element, and you'll see in our drop down we have one runtime virtual texture, the one we just set up. So select it, and now the landscape has the option to write to this runtime virtual texture. And I'm noticing that as we're changing things in the landscape, the PCG graph is regenerating. So you may want to go to your PCG volume temporarily and just switch off the generation by clicking on cleanup. We'll come and switch it back on later on. Okay, back to the landscape, back to the virtual textures. we have just set up this link from the landscape to our Runtime Virtual Texture. Step 3 now is to create a volume, and think of a volume as the projector that this virtual texture writes to the actual asset. So if I create volumes here, we've got a new volume up in the outliner, and I'm going to rename this as RVTV underscore color. Name doesn't really matter, that's just my naming convention. And we need to make sure that that volume, you can see there's a yellow line that shows what that volume encompasses. We want to make sure that volume covers the whole of the landscape. I think it does by default, but just to be absolutely sure, let's select it, and in this volume bounds here you can see the actor that it's aligned to. So it's got the landscape, and then you can set the bounds to the landscape. So if for whatever reason this hasn't been set up, you would use the eyedropper, you would pick the landscape, and then you would click set bounds, and it would set the volume to the same size as the landscape. So now we have those three elements. So we've got the asset that we're going to project onto from top down. In the landscape, we've said that we want to use that asset, and this volume here is effectively anything within that is going to be projected down. So it encompasses the whole landscape. So the final step is to edit our master material and tell it what we want to write to the Runtime Virtual Texture. So go into your master material, and here at the end of the material, before the final output, let's just create a little bit of extra space. And what we're going to do is sort of two stages. First of all, we're going to write that information to the texture. That's the base color, roughness, specular, and normal. And then we're going to also read from that virtual texture and plug it into the final output. So landscapes are interesting in that they can be used to write the texture, but you can also read from that texture as well once you've written to it. So let's take the output from our final layer blend, and we will do get material attributes, and we'll disconnect this final output for now. We'll reconnect it in a minute. And the attributes we want to get are the four I just mentioned. So if you just click on this 4 times, we're going to get our base color. We're not going to get metallic, so delete that. We're going to get specular, roughness, and the final one is the normal. So now we have those 4 attributes from our landscape. We want to write them to the Runtime Virtual Texture. So if you right click and do Runtime, there's a Runtime Virtual Texture output, and we can plug in those pins: base color, specular, roughness, and normal. So that's created our Runtime Virtual Texture. Now what we need to do is we need to read from it to generate our output. So there's a corresponding node for the Runtime Virtual Texture, Runtime Virtual Texture Sample. And it's got these various inputs here, but by default it will use the world position to dictate where the texture is going to be put on the landscape, which is what we want. We'll need to define the Runtime Virtual Texture asset we want to use. So in here we're going to use our RVT color, and now we're going to plug these back out into the material attributes. So we're going to use a set material attributes. We're going to set up those 4 attributes again. So you can see I've set up base color, specular, roughness, and normal, and we'll plug the outputs from our Runtime Virtual Texture back into our material attributes. And the final material output will go into our final output. So let's just recap on what we've done here. It's probably worth explaining how the material shade is working here, because you might be scratching your head a bit thinking, well, how can it do the Runtime Virtual Texture and the calculation? Effectively, a shader, when you're using any runtime virtual texture nodes, the shader gets compiled for two purposes. It gets compiled as if you were running it as a normal shader, and then it does all its calculations. And if I plugged this output into the main output, it would work just as it had before. But it also writes to the runtime virtual texture at the same time. It doesn't have to do that every frame. It just needs to do that when something has changed. So if we make a change in our material instance, it will go through the same code. It will write to the runtime virtual texture, but it won't need to keep updating that runtime virtual texture because nothing will change. And then instead of using the output here, we will sample from the runtime virtual texture, and it will use those tiling rules I talked about in the introduction to effectively take that texture and put it on the right parts of the landscape. And we're taking the base color, specular, roughness, and normal and putting it in the final output. We only have these four attributes here. So one thing we will lose in this approach is we used metallic on our puddles to make them darker. That's the only thing I think we'll actually lose. So if you had any dark puddles, they'll become clear again because you'll lose the metallic attribute. Everything else should remain the same. So let's save and compile this material and see what the end result looks like. Okay, so first impressions are it doesn't look too bad on here, but there are going to be some differences which I'll point out as we get closer in. So let's go down into the valley a bit more. You might see this message here, resizing virtual texture pools. There is a parameter that you can change in the project settings, but we'll leave that for now. And the first thing that you might notice is that the tiling close to the camera is no longer different from the tiling at the back. Remember, we used the camera depth to switch between near tiling and far tiling. That's because our original shader is a camera dependent shader, and it was able to recalculate as we moved around. Now we've created a top-down projection. It has no concept of camera, so it just had to use the far tiling. It didn't have a mask available for that near tiling, far tiling switch. So we now only have one texture tiling ratio. However, there are ways around that. I'm not going to cover it in today's tutorial, but in a future one, I will look at things like the relative performance of RVT versus the original material, and I'll show you how you can put that depth switching back in. The other thing that is different as well, and you may or may not have noticed, is that we have lost our triplanar projection. And again, if you think about it, the reason for that is because the runtime virtual texture is a top-down projection. So it has no concept of textures on the Z plane. So if you may as well switch off the use triplanar because it might actually muddy up these textures anyway. So in your material instance, go down to the cliff section and uncheck use triplanar, and that should make these cliffs a little bit clearer and cleaner. But it's, as I said, it's not bad. Runtime virtual textures are fiddly. There's lots of parameters that you can change, and you might find that some of your textures in the distance, in fact I can see over in this far distance, it's a little bit blurry. So we can change settings in the runtime virtual texture asset and others, but I don't want to get hung up on those today. So before we do the second half of this tutorial, let's just add a switch into our master material so we can switch the runtime virtual texture on or off, whether we show it or not. So it's pretty straightforward. Go back to our landscape, and what we'll do is we will create a switch before the final output. So do a static switch parameter. I'm going to call this parameter show RVT. I'm going to put it in the landscape general We can leave the priority at 32, that's fine. And if the show RVT is true, we're going to plug in the output from the Runtime Virtual Texture sample. But if it's false, we're going to bypass this whole section here and come out of our landscape layer blend and plug that in there. So let's just move these things around a bit. And now we have two paths through the material. One that takes the original material if we don't have that show RVT flag, and the other one that takes the Runtime Virtual Texture output and shows it. Notice that even if we set this to false, we're still going to write to the Runtime Virtual Texture. And this is important because even if we don't show the RVT, we might want to use it, as I'm just about to show you, to blend in with our grass, tree and rocks on the surface. So let's finally put a comment around here and call it RVT. And that's the first part of the tutorial done. So I said at the start of the video there were two main reasons why Runtime Virtual Textures are used. The first is to replace the standard material shader, which is what we've just shown. But the second and very useful option is to blend our objects on the surface with the textures. So things like our rocks and our grass, we can now use that color information underneath them to blend into the landscape. So before we do that, let's switch off the Runtime Virtual, showing the Runtime Virtual Texture here. It'll still write to the texture, but we just won't see the output. So go back to your landscape, make sure it's saved and applied. And then back in your material instance, you should now see that show RVT flag. And if we check it on, you'll see the RVT, but if we switch it off, it'll go back to the regular material shader, and you should see that you've got your near tiling back in the landscape. So let's stick with that, and what we'll do is we'll create an object that we can use for demonstration purposes. Once we've got things working on that, we'll then apply the blending to our stones and grass. So what I'm going to do is add a new shape, a cube, and we will put this in the landscape. And again, I'm just going to put it so that it goes about halfway into the landscape here. And we'll set up a very quick material for this using our grid textures, just so we can see the difference between the original texture and the blended texture. So open up your content browser. We'll do this in the materials folder. We can always throw these materials away afterwards, but I'm going to create a new material called M Cube. Open it up, and we're going to do texture sample, duplicate that. Our first texture sample is going to be the white grid, default white grid. Plug that into the base color. Our second one is going to be the grid normal, grid underscore N. So these were the same ones we set up for our landscape. Plug that into the normal, and then we'll set the metallic at 0, specular 1, roughness 1, and that will do. So we will click save, and we'll set up a material instance for this because we'll want to set up a parameter later on to control the blend. So right click on your material cube, create material instance, and call it MI cube. And while that's selected, go back to the cube, find the material on the cube and use the selected asset, and you should see our grid pattern on there. Might be useful to have it a bit bigger, so let's scale it. Go up to the scale and scale it 2 times. That's fine. So now we've got the grid pattern on there. Right, do a quick save of the project. And let's talk about how you use the Runtime Virtual Texture asset to blend in with an object. We will do the absolute basics to start off with, and then we'll refine it as we go along. So if you imagine that this object, if you are rendering it, each part of this object has X and Y coordinates on the landscape. And underneath it, our virtual texture also has world position X and Y coordinates that store that color. So if we get the texture, runtime virtual texture based color at the same coordinates, we can put that onto the object in place of its existing material. Maybe sounds more confusing than it actually is. Let's actually do this. Let's create a material function which will override our base color. So let's go to our material functions folder and we'll create a new material function here. So under the material subfolder, material function, I'm going to call that MF RVT Blend. Double click. And this is going to be almost as simple as you can imagine. We're going to have an output, which is going to be a RVT color. And then we're going to select our runtime virtual texture sample. That's our runtime virtual texture that contains all our information. Make sure you select the one we've created. And by the way, I didn't mention this before, but if you look at the little thumbnail here, you can see that it's showing you the color information of our landscape. That's the snowy mountain at the top there. That's the valley here. So that is what has been generated into that runtime virtual texture asset. Just gives you that reassurance that it's actually working. So what we can do is we could just simply plug this base color into the output here. And then we could use this function to override the base color of any object. As I said, world position is the default, so it will take the X and Y position of the object. So save that. Let's leave it open so we can come back and refine it later. But now if you go back to the object here, what we want to do is we want to open up our material for the cube. So go back to your top, your materials level, open up the material cube. And what I'm going to do is I'm going to, instead of plugging our grid sample here, I'm going to use this material function. So in your material function, find MF RVT Blend. Here it is with an output of color. So instead of using the texture sample, I'm going to use the RVT asset color. And what you can see is that although the normal is staying the same, we have the texture color from beneath it. And if you're thinking it looks a bit bigger, that's because of the scale issue, because it's using the far tiling. If you want to show that the near tiling would work, we can temporarily, on our material instance over here for the landscape, let's change the far tiling size so it's the same as the near tiling size. And after a short calculation, you can see that this color now matches the color underneath. So could we do the same thing for the normal information as well? Well, let's add that in. Let's go to our RVT Blend and let's add another output. So let's duplicate this one and call it RVT normal. And let's plug the normal from our sample into that there. Save and compile it. Go back to our material cube, and now we have another element here as well. Actually, we'll probably want to put them in a different order. So go back to the blend and make the color sort priority 1 and the normal sort priority 2. Save that. And now this is the other way around. And now again, we'll ignore the normal for the grid sample and we'll plug the normal from the texture in here. Save. Come back and look, we've now got the top of this cube looks pretty much the same as the underlying texture. Now, you probably noticed the elephant in the room here. The sides are vertical lines, and that's because it's a top-down projection, there is no change when things are perfectly perpendicular like this. But in reality, most of the things we're going to have from the landscape, the rocks and the grass, aren't going to be like this, so it won't look too bad. And if, for example, I rotate this object a bit, let's rotate it like this, you can see that that is a better blend there. It's a bit light, but again, we can play around with these blends and we can tint them so that they match the surface. But that is mirroring what's underneath. However, this is a little bit of an unrefined approach. What we want to do is we don't want our materials to be exactly the same as what's underneath them. We want them to take what's underneath and blend them up to a certain point and then go back to their original textures so that they fit in with the landscape a bit better. So let's work a bit more on our blend function and see if we can do that. So back in our RVT blend function, let's disconnect the sample here. What we want to do now is blend between the original color and normal and the Runtime Virtual Texture sample based on the height above the ground. So we'll need two inputs. Let's just move this down out of the way for a second and type input and do function input. We'll call the first one color, and it's going to be a vector 3, and then we will duplicate that. We'll call this normal, and that's also a vector 3 as well. So if we passed these straight through, then the color and the normal would be unchanged. Now we need a mask based on the height in order to switch or blend between this color and the color and this normal and the color and normal from the Runtime Virtual Texture sample. So first thing we'll do is get the world position, and we want to take the height, which is this Z value, and then we want to find the height of the landscape to see how high this position is above the landscape. And this is where you might scratch your head and go, well, we don't have that height information. Well, Runtime Virtual Textures will come to the rescue again, because you can also write height information from our landscape to a Runtime Virtual Texture. So let's go back to the main level here, and what we need to do is set up, just like our 4 steps for setting up the RVT asset for color, we'll need to do the same steps for the height. So if you remember, the first step was to set up an asset. So let's go into our RVT folder where we've got our RVT color, and right click, new texture, Runtime Virtual Texture. We're going to call this one RVT Height. And if you open it up, instead of storing the base color, normal, roughness and specular in this asset, we're going to store the world height. And you probably don't need as much resolution for this, so let's leave these values at 8 and 2 and click on save. That's step 1 done. If you remember, step 2 was we select our landscape, go down to the virtual textures. So at the moment we're drawing in our color virtual texture. We'll need to add a new element here, and from the drop down select the RVT height. And so we're saying that we want this landscape to also write height information into a virtual texture as well. We'll need to create a volume for this. So let's just take our RVT color that we selected earlier. Remember, this is the volume that surrounds the whole landscape, acts like our projector of anything with inside it. So duplicate this with Control D, rename it to RVT Height. Make sure that you have got the RVT Height asset selected in the virtual texture, and then what we will do is we'll use the eyedropper tool to select the landscape and then click on Set Bounds, although because we copied it, it probably worked exactly the same as before. And you can see that yellow line in the distance is the volume that surrounds the whole landscape. So that all looks pretty good. And the fourth step was to update our landscape material to write the height information to this runtime virtual texture. So go back to your main landscape, and you can see that in our runtime virtual texture output, we've got this height element here. All we need to do is take the world position of our landscape and plug the Z value into the world height. And so as it's generating this landscape, it will write the height information into the runtime virtual texture asset, and then we'll be able to use that to do our texture blending. So click on Save. Nothing will appear to have changed because we haven't used it yet, but if you've still got your runtime virtual texture volume open here, you might have noticed that your runtime virtual texture height asset here now has this black and white mask that shows the height. So you can see the white highest values for the snow-capped mountains and the black values of the valleys. So that implies that that height information has been captured correctly. So we'll go back to our runtime virtual texture blend, and now we can continue to create our mask to blend these two textures together. So we'll take we've got the output here for the height, the actual height, and let's move that underneath, and then we will do a subtract. So we'll subtract the height of that part of the object from the world height from our runtime virtual texture sample. Now you will need to make sure that this runtime virtual texture sample is not RVT color. We want RVT height. Otherwise there won't be any height information in that sample. So do that. Now just let's talk through how this works. If the with our cube, if the part that it's rendering is at the same height as the landscape, this will be the same as the world height, and the subtraction will result in a 0. If this is higher, so say it's 100 units higher, then this will result in 100. So what we want to do is we want to use a divide to get it into the range of 0 and 1 for our mask. So if you do a divide here, and we'll create a parameter, so S and click, and we'll call this blend distance, and we'll set it to default of 100 and plug that in. So that means that anything that's within the first 100 units will be reduced to 0 or negative value by this division, and anything that's above 100 units, once divided by 100, will be above 1. So that will be our mask cutoff. Now, at some point, you'd probably want to add other features to do maybe some sort of contrast and things like that. But let's keep it simple for now, and we'll do more sophisticated stuff in a future episode. Let's just get it working for now. So we need to get this into a 0 to 1 value. So let's do saturate. Now it is a mask with 0 to 1. And let's just actually have a look at this. Let's plug it into the color output here, and then we can see what it looks like on the cube. So click on Save, and here we will have to plug in our values, even though we're really not using it at the moment. Click on Save. It's saying that there is an error at the moment. Let's see. It's missing a connection. Okay, so we need to go back into the blend and we need to just connect something to the normal. So let's just collect the input normal to the output normal. Okay, no errors now. And come back here, and what you can see is a very sort of light gradient at the bottom. So that is those first 100 units where the mask is going from black to white. So if we go to our cube, in fact, no, go to our RVT blend, and let's change that blend distance to 1000. You can see now that the mask is much grayer there. So we have the mask there. Now we can use that to do a lerp between our original texture and the underlying Runtime Virtual Texture color. So in fact, let's come into our cube here, and I see what we've done here. We've plugged these into the wrong thing. So the color should have been in the color and the normal should have been in the normal. So let's come out here and change these to input priority 1 for the color. Normal should be input 2. And you can see now I can plug these into the right inputs. Okay, so now we have color and normal to normal. Click on save. And there's our texture. We've still got the original normal on there, but you can see there is this light gradient between the bottom where it's darker and lighter at the top. So we can play around with those values in a second. And actually we're not going to change this main master material anymore. Let's open up our material instance for our cube. So back in the materials layer, let's open MI cube and let's just put it over to one side for a second. So we've now got our blend distance as a parameter here. So if we go back here, we can play around with that. So if we make it 0, you can see that the mask is completely white. If we make it 500 grey, 1000 darker, 10,000, it's starting to go even darker. So as I said, we're going to add more to this in a future episode, but this is really just the starting block for doing the blending. So let's put it back to something low, 500, and I will just dock that with the material instance so we can come back to it in a second. Okay, so we've got the mask. Now let's use that mask to lerp between the original color and normal and the color and normal from the Runtime Virtual Texture. So what we'll do is we'll get our Runtime Virtual Texture sample. This time we want to use the RVT color because we want the color and normal information, and using the L key we'll create a lerp, and where that mask is black at the bottom of the object we'll have a value of 0, so we'll put in our base color, and where the mask is white we will put in the color, and then we need to plug this output into our alpha for our mask. And then we'll do the same thing. Let's move, in fact let's comment this, let's call this height mask. And the output of this lerp goes into the color, and then we want to do the same for our normal. So duplicate this lerp, plug the Runtime Virtual Texture normal into the top pin, the original normal into the bottom pin, and the mask into the alpha, and then the output from this goes into our new normal. And I think that is everything done correctly. So click on save, come back to here, and you can see that we have a bit of a blend going on, but it's very light. So you can see on this side here you're starting to get a little bit of the color and a little bit of the normals of the color underneath, but it's very weak at the moment. So let's up the blend distance. So I'll make that something really ridiculously high, 50,000. And you can see that it's fully blended now along with those strange lines on the perpendicular parts. So that's emulating what we did without the lerp. But if we put that back down to something like 1000 or 2000, we've got a blend between the underlying texture and the texture up here. And as I said, we can add some other variables here to tint that blend if we want to make it match even better. Okay, so that's our basic RVT blend function done. Let's now use that function and apply it to our grass and rocks in the landscape. So let's apply the blend to the grass first, because I think this has the biggest impact on gluing those meshes to the landscape. We'll need to switch the PCG volume back on. So select your PCG volume, click on generate. So we regenerate our grasses that we switched off a short while ago. And here they are back on the landscape. Right, so you can see at the moment they're a very distinct shade of green that's different from the underlying ground color there. So what we can do is we'll need to find the master material for the grass, and we'll need to inject our RVT blend functionality between the colors and normals on the output. So let's find those meshes first of all. Go into the foliage collection, meshes, grass mesh, and the main one was this grass 0103 mesh here. So if you double click on that to open it up, and then you will then browse to the material, open that up, and there are various parameters here, but we need to change the master material. So the very final material we need to navigate to is this MA grass master material. So browse to that and open it up, and you can see this is where all of the material logic happens for grasses. And you can see that it's using base color, specular, roughness, normals, etc. So all we need to do is put in our RVT blend before this final output. So in the content browser, find your material functions, find the MF RVT blend and drag it in here. And then between the base color and this desaturation node, we will plug in the color and the color output. And from the normal output or input pin here, plug that in there. And the normal comes out of this flatten normal node here. So we've just put the blending between the color and normals that were originally being output. Save that. If you close that down and you come back to the material instance that we were in just before, you'll see there's now a new blend distance. We left the default at 1000 there. So it'll be interesting to see. Let's put that over on the right hand side so we can see it at the same time as the element here. And you can see that after a second or two while it recalculates, you can see that now we have a distinctly different looking grass. So again, I'm seeing some resizing virtual texture here. So it's sorting out the RVT size. But now have a look at those grasses. So if I look at the grasses over in this bit here, can you see that the ones that are in the dusty, dirty ground here are completely brown because they've taken the brown texture underneath and they're taking that for the whole of the color. Whereas ones that are in the grassy parts of the landscape are retaining the green, and any variation in color in that underlying texture is also represented in that blend as well, although the blend's a bit strong at 1000 at the moment. If those resizing virtual texture pools annoy you, by the way, what you can do, and you see it's coming up quite a bit here, is go into your project settings, search for the word grow, and instead of doing this pool auto grow in editor, turn that off. That will stop the RVT streaming pools being grown automatically. Okay, so it's definitely working, but we need to tone it down a bit. So let's go back to our parameter here for blend distance on the grass, and actually just make it 0 to start off with. If we make it 0, our grass goes back to its original unblended color. But if we do something like, say, 200, we get a little bit of both. So we get brown in these brown parts of the landscape. There's brown at the bottom of the grass, but at the top it is still retaining a little bit of the green there. So it's a really powerful technique, and it's made a whole difference to this grass and believability that it really did grow on that landscape. So we're almost there for today. As I said, it's been a long one today, and we still haven't covered everything RVT has to offer. But let's finish off by changing our rock to do a similar thing. Okay, I'm back in the RVT Blend material function. I just wanted to change the default value for the blend distance to 100, so it's not full on whenever we apply this to a new material. Click on Save here, and now we need to find our stone material in order to change that. So go into your content browser, go into Fab, Small Stone, Medium, and we need to go into our material instance for the stone. We're going to be using that in a second, so let's just drag that over to the right hand side. Then navigate to the parent material, and notice, by the way, that the parent material is actually in the engine. It's in a Fab material standard, so if you change it, you'll actually be changing it for all Fab materials. So we probably want to copy this one and put it in our project. So select it, go into, in fact, it might be easier if you do it on a bigger screen. So let's move that over a little bit. What we'll do is, you can see there it's in the engine content here. It's called MS Base. So let's actually go to our main content, go to materials, and what we'll do is, don't click on that, drag that from here into materials and choose copy. If you then look in your materials folder, you'll have another one called MS Base, but what we will do is we'll just rename this and put RVT on the end. And now we've got this copy. In our material instance for the rock, we will change this MS Base to MS Base RVT. So search for base RVT and select that one as the new parent material. Okay, now we can push that back to the right, navigate to it, open it up, and this is a pretty straightforward material here. So it literally just has these named reroutes plugged in. So we need to do the same thing as we did for our grass and just plug our RVT blend between the color and the normal. So find the material function, RVT blend, drag it in here, and let's just move the albedo and the normal over a bit. Move this in between, and we'll plug the color into RVT blend, color, and the output into color. We'll plug the normal into the normal input and the RVT normal out, and click save. Look over on the right hand side and you'll see a blend distance. By the way, we didn't give it a group, it's just a global scalar parameter. So let's quickly fix that. Go to the RVT blend, find our blend distance and give it a group name of RVT. and save. Now you can see that our blend distance is in a group with a meaningful name. We can come back to our elements here now, and if we find a rock somewhere on the landscape, and you can see that it has some blending going on here. So let's reduce that to 0. That's what the original rock looked like, and with a blend distance of something like 20, you can see that it just has a little bit of blending at the bottom of the texture there. So we can change the blend distance in our material instances to be different for different objects, but you can see that it's a pretty powerful technique. So I think that's enough for today. It's been a long episode and there's still a bit to cover with RVT, but I'll save that for another day when your head's cleared. We will continue on the next episode with, I think we're going to start looking at water levels. So we'll actually create another landscape in the next episode. We'll create an island with an ocean around it, and then we'll look at how we can do a height-based mask at the water level to prevent your slope information being propagated beneath the ocean. So stay tuned for that one, and I'll see you next time. Bye for now.